Hello, sixth period. Even though I'm in California, I still will be helping you with the next section, 2.2, which is called Combined Inequalities. That tells us that we're going to start graphing on a number line more than one inequality. If you remember, an inequality is the opposite of an equation. An equation is an equal sign. An inequality is less than, greater than, less than or equal, greater than or equal. Now, also remember, when using a number line, if the problem has a less than or greater than symbol, we have an open circle on that number. If the problem uses a less than or equal, greater than or equal sign, we use a closed circle on that number. Same thing applies here. Before we do any examples, we need to talk about a couple things first. Now, for this section, I expect you to write everything that I'm writing down, you write down in your notebook. Let's begin. Alright, now, when I say combined inequalities, I'm talking about two different types of inequalities. The first type is called an AND inequality, which is also called a conjunction, or there's an OR inequality, which is called a disjunction. Now, here's what that's going to look like. If your combined inequality is an AND statement or a conjunction, that means when you plot your two numbers, okay, let's say one of your numbers is over here, some positive number, doesn't matter. Let's say there's an open circle. Let's say your other number is some negative number over here. Let's say it's a closed circle. If it's an AND statement, you can tell because when you shade each number, they're going to shade towards each other. Okay, you're going to overlap when you shade. That's when you know it's an AND statement. An OR statement or a disjunction goes like this. If you have 0 and let's say your number's over here, let's say it's a closed circle and let's say this is also a closed circle, doesn't matter. Well, if you have an OR statement, that means they're going to graph away from each other. If they graph away from each other, that is an OR statement. You'll see now when we look over a couple of examples. So this first example, obviously, because it says so, this is an AND statement. These should shade towards each other. Let's see if they do. Okay, you would draw your number line, start with 0 in the middle. X is greater than negative 2. Well, here's negative 2. That would be an open circle. Okay, X is less than 4. 4 would be to the right of 0 because it's positive, and that would also be an open circle. Okay, so now for the shading, we want the same number X to be both bigger than negative 2 but also less than 4. Well, numbers that are bigger than negative 2 go this way. Numbers that are less than 4 go this way. So as you can see, your graph shades towards each other, which is an AND statement. Well, what's going to happen when it doesn't say AND? Well, key to this kind of problem is whatever you have in the middle. In this case, it's only X, so it's not going to be that big of an issue. Whatever's in the middle, you need to keep together. Don't split it up. You'll see what I'm talking about later on when we look at a couple examples. Okay, now, there are two inequality signs in this problem. Therefore, there are two inequalities you need to separate. The first is X is less than or equal to 1/2. The second inequality is X is greater than or equal to 0. Notice Because my symbol is opened up towards the x, I'm going to keep it opened up towards the x. There are your two inequalities. So let's graph them. There's 0. We're going to have a closed circle on 0 because it's greater than or equal to. 1/2 would be right over here. It's also going to be a closed circle because it's less than or equal to. So this problem says we want some number x to be greater than or equal to 0 or less than or equal to 1/2. What would that look like? Well, greater than 0 is going to be this way, less than 1/2 is going to be this way. So I'm shading in between those numbers. Any number between 0 and 1/2 would be an acceptable answer. Here's an example of an OR statement. Clearly this is an OR statement because it says so. Well, like we said earlier, OR statements should shade away from each other. So let's see if that happens. If you draw your number line with 0 in the middle, you would have -3, which would be over here with an open circle, and you would have +2 with an open circle. Now we want to shade where our number x is less than -3. Well, numbers less than -3 would shade this way to the left of -3, and our number x bigger than 2 is going to shade to the right of 2. Notice this OR statement shades away from each other just like we said it would. So here's another example of a problem that does not say and it does not say or. So we need to be able to determine what kind of statement it is. Well, first, remember what I said. See what's in the middle. Obviously y plus 2 is in the middle. We do not want to split that up. There are two inequalities in this problem, so we need to split up two inequalities. Well, don't split up the middle. Here's how you want to separate them. Keep the middle intact and use the right inequality. So you're going to have y plus 2 is less than 2. Your second inequality is going to be the middle with the left inequality. Y plus 2, it's open towards y plus 2, so I'm going to keep it open towards y plus 2 with a 0. Make sure you don't split up the middle. Now, we need to get y by itself, so we need to actually solve this. Well, all we need to do to solve this is subtract 2 to both sides. So y is greater than or equal to -2. There's one inequality. And subtract 2 to both sides. Y is less than, well, 2 minus 2 is 0. There's your second inequality. Now we need to graph. Okay? There's 0 in the middle. -2 is over here. It's going to be a closed circle because it's greater than or equal to. Y equals 0 or less than 0. That's an open circle on 0 because it's less than. Now we need to figure out where we're going to shade. Well, we want our number y to be bigger than or equal to -2. So that means I'm starting to shade this way, to the right. Well, we also want that same number y to be less than 0. So I'm going to start shading left of 0. Well, where did you shade? You shaded towards each other. So this would be an example of an AND statement. Here's another example. Once again, notice what's in the middle of your two inequality symbols. 3z plus 2. Do not split that up. Here's one inequality. The middle with the right inequality. So 3z plus 2 is less than or equal to 8. Here's your second inequality. The middle and the right, or excuse me, the left inequality. 3z plus 2, it's open towards 3z plus 2, so I'm going to keep it open towards 3z plus 2 with a -1. Now we need to solve for z for both of these. So this first one on the left, you're going to subtract 2. You get 3z is greater than or equal to negative 3. You're going to divide by 3, and you get z is greater than or equal to negative 1. Your second inequality, you're going to subtract 2. 3z is less than or equal to 6. You're going to divide by 3. And z is less than or equal to 2. Now when you graph, you're going to graph those two numbers. So we have 0 in the middle. Negative 1 is right here. That would be a closed circle. Positive 2 is over here. That would also be a closed circle. Now think about where you're going to shade. We want numbers, z, to be bigger than negative 1. So I'm going to start shading this way. Well, at the same time, we want that same number z to be less than 2. So I'm going to start shading this way. So notice you're shading towards each other. This is an and statement. Hopefully the first thing you notice about this example is it tells you this is an or statement. So we should shade away from each other. If you don't, you did something wrong. So let's check. First of all, it's already split up for you. Or statements will already be split up for you. You don't need to split them up like we did on the last problem. So now we just need to solve it. So for this first example on the left, you need to subtract 7 to both sides. 3k is less than negative 6. Divide by 3. And k is less than negative 2. There's one answer. The second answer, you're going to add 3 to both sides. 2k is greater than 4. Divide by 2. K is greater than 2. Once you come up with your answers, graph them. 0's in the middle. Negative 2 is over to the left. It's an open circle because it's less than. Positive 2 is over to the right. It's an open circle because it's greater than. So where are we going to shade? Well, we want some number k to be less than negative 2, so I'm shading to the left. We want that same number k to be bigger than 2, so I'm shading to the right. This is obviously why this is an or statement. They shade away from each other just like they should. So there is 2.2 combined inequalities. Hopefully you notice that it's really nothing new compared to the first section we learned. The only difference is now you got to solve 2 inequalities instead of 1, which means you need to graph 2 inequalities instead of 1. The one trick is make sure if you have to split up an inequality like we had to on a few examples, do not split the middle up. Keep the middle the same on both examples. Last thing, don't forget, anytime you multiply or divide by a negative number, what has to happen? Hopefully you remember you need to flip your sign. If it's less than, flip it to greater than. If it's greater than or equal, flip it to less than or equal. That's extremely important. If you don't flip your sign when you need to, your shading will be off. An or statement will all of a sudden shade towards each other, which is not supposed to happen. So keep that in mind. So your homework is page 67, 2 through 32 evens. Enjoy your homework.